Hey guys, and welcome back to the only channel bringing you BMET tips and tricks to make it through the schoolhouse. Today in class we covered semiconductor fundamentals and diode limiter operation. Diode limiters look difficult, but once you get the hang of it, they're a piece of cake. So let's get after it, shall we? Semiconductors include diodes, transistors, and other solid-state devices. Diodes are made of a crystal-like material doped with impurities to create a compound whose electrical resistance is greater than that of a conductor, but less than that of an insulator. They are usually made of silicon or germanium. Doping is the process of introducing a specific type of impurity into a pure base material. These impurities allow us to turn the diode on and off like a switch. The cathode possesses a negative charge and is represented by the red bar in the drawing. The cathode contains an excess of electrons and is made of N-type material. This brings us to the anode, represented by the blue triangle in the drawing. The anode possesses a positive charge and is made of P-type material. So an easy way to remember this, right? Cathode, N-type material, cats are negative. The anode is positive P-type material. So positive charge P-type material. This brings us to the depletion region known as the PN junction, which is doped with both P and N-type material and possesses a neutral charge. When a diode is forward biased, which we'll get to in a second, the voltage drop seen across a silicon diode is 0.7 volts and 0.3 volts for a germanium diode. This voltage drop is called the knee or offset voltage. This brings us to forward and reverse bias. When a diode is reverse biased, it will act as an open switch and have no current flow. When using an ohm meter to measure resistance, a high reading will be measured and the diode's voltage drop will measure the circuit's applied voltage. Now to talk about a forward bias diode. A forward bias diode acts like a closed switch, meaning that we will have current flow. However, the resistance of a forward bias diode is not zero, it's low. Again, the voltage drop across a forward bias diode is 0.7 volts for silicon and 0.3 volts for germanium. To get a diode to conduct, we must have 0.7 volts greater on the anode compared to the cathode, and 0.3 for germanium diode. First, we should check the orientation of our diode in the circuit. A super easy way to tell this is to compare the polarities of the diode in the circuit. Look at the reverse biased circuit first. The negative terminal of the battery and the positive side of the diode are connected. This is reverse biased. If we look at the forward biased diode, we notice that the polarities of the diode and the circuit match. Same. Now let's take a look at the reverse biased circuit for a second. Imagine you're on a bike, leaving the negative terminal of the battery, and you run right into D1, right? It's like running right into a wall. Now if we look at the forward bias diode, and we leave the negative terminal of the battery, and we hit a sweet ramp. Now going off that sweet ramp, you made it past the diode, so current will flow. Some common types of diodes are the light emitting diode, or LED, and the Zener diode. An LED releases its energy in the form of light and is used as an indicator. The Zener diode is used as a voltage regulator and maintains a constant voltage drop over a range of current flow. Now for transistors. We're not going to do a deep dive, you'll get that in course 102. You need to know how the three portions of a transistor are doped. A transistor has three regions or terminals. An easy way to remember them is the alphabet. B comes first and is lightly doped, C comes next and is moderately doped, and E is third and is heavily doped. Now for everyone's favorite part of course 101, diode limiters. These are super easy. The part of the diode that touches the output is the portion of the signal we're going to remove. As you can see from the first illustration, the series positive limiter has the positive side of the diode facing the output. This causes the diode to be reverse biased when the positive portion of the signal hits the diode and forward biased when the negative portion of the signal hits the diode. This allows the negative portion of the sine wave to be seen at the output. If we take a look now at the parallel negative limiter, what part of the diode is touching the output? It's the negative side of the diode, right? This means that when the positive portion of the signal hits the diode, it will be forward biased, and when the negative portion of the signal hits the diode, it will be reverse biased. That brings us to series and parallel limiters with bias voltage. All a bias voltage does is raise or lower the voltage seen on the output. A positive bias voltage will raise the limiting point and a negative bias voltage will lower the limiting point. Remember to pay close attention to what terminal of the battery is facing the output. That will determine the polarity of the bias voltage. The easiest way to do this is draw out the waveform. Start with the bias voltage. In the series limiter illustration, the positive terminal of the battery is facing the output. Draw in a positive 5 volts on your graph. Then draw in a sine wave. Now that the negative portion of the diode is facing the output, remove the portion of the sine wave below positive 5 volts. We can do the same thing with the parallel positive limiter with negative bias voltage. Go ahead and pause the video and try it for yourself. First thing we look at is the bias voltage. Since the negative terminal of the battery is touching the output, we know it's a negative bias voltage at negative 5 volts. Draw it in on your graph. Now draw in a sine wave. Since the positive portion of the diode is touching the output, we're going to remove everything positive of negative 5 volts. Too easy, I know. Alright guys, we covered semiconductor fundamentals and diode limiter operation. Best of luck to you on your Day 17 PC and course test. If you liked the video, don't forget to hit that like button and subscribe for more BMET tips and tricks. And as always, stay classy and keep your head up.